Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to everyone. And today we are going to present for our assignment vehicle dynamics assignments. We are from 3 BMKA to stroke 1 from group E. And the topic is semi-active suspension system. And my teammate consists of me, Ahmad Ilham Al-Karl bin Muhammad Anuar, Ahmad Daniel Zainurin, Darwish Ashraf bin Abdul Samad, Muhammad Arief Ridzuan bin Muhammad Zaid, and lastly Muhammad Iman Haqiemi bin Muhammad Zaki. And our lecturer is Engineer Technologist Dr. Muhammad Hafiz bin Harun. For introduction, for semi-active suspension system, evolution in automotive engineering, the ever-changing landscape of automotive engineering introduced the semi-active suspension system as a notable innovation. For dynamic balance, semi-active suspension system, unlike traditional passive and fully active system, semi-active suspension system strike a dynamic balance, offering flexibility and adaptability. For real-time adjustment, this technology enables real-time adjustment to damping levels, responding to swiftly to varying driving condition for an optimal driving experience. Next, is the blend of comfort and performance for semi-active suspension system. By seamlessly combining comfort and performance, semi-active suspension system enhance ride quality, vehicle stability, and overall handling. This is our literature review or a summary for the journal that we took for our research. First one is online estimation of road profile in semi-active suspension based on unsprung mass acceleration. The second is semi-active suspension system research to mass market. The third one, control of new loss cost semi-active vehicle suspension system using artificial neural network. The fourth is semi-active suspension control, improve vehicle ride and road friendliness. And lastly, a semi-active suspension using a meteorological damper with non-linear negative stiffness component. For this is next is the discussion of the journal that we have get. First one, the journal one, which is the online estimation of road profile in semi-active suspension. The methodology, if you see here, there are actually one, seven methodology, which is model-based approach system, numerical model, road disturbance estimation, road roughness classification, influence of time window and parameter variation, test bench validation, the comparison and validation test. But we are going to compact everything, and we are going to take only 3 points from the methodology, which is first is comparison of methods. The author compared the system dynamic response based method with the neural network based method and highlighted the advantage of the former, such as good transplantability, low cost, and less computational load. Next is limitation of system dynamic response based method. They acknowledge that the system dynamic response based method has shortcoming, such as influence of parameter variation on estimation accuracy. And then is the validation of online estimation method. They conducted tests to validate the estimation and classification performance of the online estimation method of road profile. The result demonstrate the method adaptability and accuracy under variable environmental condition, including variation in damping coefficient, sprung mass, and vehicle speed. As for the result, the online estimation method for road profile in semi-active suspension, the method involved a model-based approach using quarter vehicle linear model, a road disturbance estimator based on unsprung mass acceleration, and road roughness classification method based on power spectral density, which is PSD estimation. The study verified the adaptability and accuracy of the online estimation method under variable environmental conditions, including variation in damping coefficient, sprung mass, and vehicle speed. The comparison with existing method highlighted the method's superior classification accuracy, reaching 98.5%. And then the study also investigated the impact of parameter variation in semi-active suspension on estimation accuracy, demonstrating the method robustness and sustainability for real-time road profile estimation. So the result indicates the potential for future research to integrate road estimation and suspension control to enhance handling stability and ride comfort. Next, we are going to give to the next presenter.
Hi, Assalamualaikum warahmatullahi wabarakatuh. A very good day. I will continue journal 2, which is I'm gonna try to share about the methodology and key finding from our research paper on suspension, technology evaluation, and the performance evaluation of semi-active dampers. First, we go to the methodology, historical analysis of suspension technology evaluation. The paper initiates with the historical analysis, tracing the evaluation of system technology from passive to fully active system. This methodology involves examining pivotal developments, identifying key challenges, and the understanding to the context that lead to the emergence of semi-active suspension system. Next, we go to the collaborative trend analysis in the automotive industry. An analytic approach in use to study collaborative trend between major car manufacturer, which is Audi, VW, Mercedes, Ford, Volvo, GM, and the suspension suppliers such Technico, Bilstein, and more. This methodology aimed to uncover pattern and collaborative effort in the development and implementation of semi-active suspension system. And we're moving to the performance evaluation of semi-active temper. The paper employs the performance-based methodology to assess the strength and the weakness of the various semi-active tempers. Evaluation criteria include speed, cost effectiveness, simplicity, and the adaptability. Real-world examples such as a lesson curve, wheel stains, Nemtronic select are used to illustrate the practicality of this temper. Now we go to the result. For the first point of the result, a close look at the manufacturer-specific semi-active suspension system. In-depth insight into the specific system by manufacturers like Volkswagen, Jaguar, Land Rover, and Ford, finding may include in unique features, effective sensor integration, and well-optimized control algorithm. And next, we go to the last for the result, unraveling the strategies behind semi-active suspension control system. As we dive deeper, we unravel the strategies behind the semi-active suspension control system. Our exploration revealed a combination of classic strategies like skyhook and ground hook, along with the advanced one like model predictive control and fuzzy logic control are employed. This combination is found to exchange overall performance. To wrap up, our methodology has taken us through the historical evaluation of suspension technology, collaborative trend in the automotive industry, and the detailed performance evaluating of semi-active temper. The close look at the manufacturer-specific system and the exploration of control strategies add deep to our understanding. That's all from me.
Okay, thank you to the Iman Haqiemi. Okay, I'm going to continue the presentation about the Journal 3. Okay, about the methodology. First of all is introduction of artificial neural network. For the short form is ANNS, which is using artificial neural networks helps This low-cost suspension system adjusts to different road conditions in real time. Okay, next is need for low-cost solution. Okay, ANNS process information fast, making the suspension system react swiftly to change in the road, improving both comfort and stability. The system is cost-effective compared to high-end option, making advanced suspension control accessible without breaking the bank. The next is learning and adaptation. The system remains functional even if some sensors fail, thanks to the fault-tolerant capabilities of ANN. By adjusting damping rates on the fly, this system optimizes energy consumption, which is great for fuel efficiency or electric vehicle range. Okay, as the result is expect a comfortable journey as the adaptive control minimize vibration and impacts. ANN seamlessly work with different sensors, ensuring reliable and accurate suspension performance. The system is versatile, ready to accommodate new features or upgrades down the road, keeping the vehicle up to date with evolving technology. For the conclusion is, in summary, using artificial neural network to control a new low-cost semi-active vehicle suspension system bring exciting improvements to the driving experience. It makes car more comfortable, handles better, and does so without breaking the bank. This technology is a step towards making advanced features available in wider range of vehicle, ensuring everyone can enjoy a smoother ride on the road. Okay.
For Journal 4, the methodology used is a quarter-car model. The quarter-car model is pivotal in advancing semi-active suspension system research by simplifying vehicle dynamics and control strategy testing. It acts as a cost-effective prototype for experimenting with damping strategies, optimizing parameters, and conducting quick simulations, expediting the research process. Additionally, its simplicity makes it valuable educational tool for understanding fundamental principles. In summary, the Kottaka model serves as a multifaceted role, facilitating innovation in semi-active suspension system. Next, the methodology used is magnetorological dampers. Using MR dampers in semi-active suspension research is a valuable methodology. These dampers, responsive to real-time conditions through magnetically induced rheological changes, offer dynamic balance between ride and comfort stability. The controllability of MR dampers allow researchers to optimize parameters, evaluate control strategies, and enhance overall system performance in semi-active suspension system, contributing to advancement in automotive suspension technology. The result of the experiment conducted is one of it is comfort in driving. The system dynamically adjusts damping rates in real time, effectively isolating the vehicle from shocks and vibrations on uneven roads. The adaptability minimizes disturbance for passengers, providing a smoother ride compared to traditional suspension. Additionally, by reducing pitch and heave, the system enhances overall stability, delivering optimal balance of comfort and performance. In summary, semi-active suspensions redefine driving comfort with their responsive and stabilizing features. That's all from me. I'm passing on to the next presenter.
Okay, I will continue with our presentation today. The title for Journal 5 is a semi-active suspension using a meteorological damper with nonlinear negative stiffness component, which is we get from the article in Mechanical System and Signal Processing. Okay, for the methodology that we get, theoretical analysis of the MR, which is we call as magnetoreological suspension, which we call the MR. The theoretical analysis for the new semi-active MR suspensions involves three key steps. Firstly, the behavior of the MR damper is examined by creating a mathematical model that considers magnetic field strength and fluid viscosity, while also exploring its response to different frequencies and control methods. Secondly, the contribution of the negative stiffness component is investigated through the development of a simple mathematical model focusing on the influence of permanent magnets and the exploration of force displacement loops generated by the negative stiffness mechanism. Lastly, the overall analysis integrates both the MR damper and the negative stiffness component to simulate the complete system's performance under varying conditions, evaluating the combined effects of controllable damping and stroke-dependent negative stiffness on vibration reduction and stability. Theoretical prediction are then validated by comparing them with experimental results, ensuring a comprehensive understanding of the semi-active MR suspension's behavior and performance. Okay, next for the methodology, experimental characterization. Set up an experimental testing environment utilizing an MTS machine to characterize the displacement force relationships of the new suspension system. Conduct tests under different conditions, including variations in displacement and frequency to validate the negative stiffness and evaluate the system performance. Okay, for the results, in conclusion, the integration of negative stiffness mechanism into a semi-active MR suspension represent a significant advancement in vibration control technology. The experimental results confirm that this innovative approach surpasses the performance of both passive suspensions and conventional MR suspensions. The achieved vibration reduction performance is comparable to that of some active systems reported in the literature. The stroke-dependent negative stiffness facilitated by a magnet assembly allows the semi-active MR suspension to self-generate an actuating force during operation, addressing the limitations of traditional MR dampers. This breakthrough design not only broadens the effective frequency range for vibration suppression, but also introduces beneficial nonlinearity. The proposed semi-active MR suspension offers a promising solution by achieving performance level skins to active suspensions while retaining the inherent advantages of simplicity, reliability, safety, and economic applicability associated with semi-active system. Uh, as you can see, the figure shown modified Book-Wen model, which is the model modified by Book-Wen. Okay, next. Okay, this is all our references. Next. Okay, thank you. That's all from us today. Thank you. Bye-bye.